Okay. Water. Oh, that's not enough water. All right. Back 1 second. Okay. That's a reasonable amount of water. What are these number 1, number 2 things that we're seeing? That's not us. I think that's a Google, that's a YouTube thing. Community leaderboard. You all have experience. Oh my God. What is this? What is the leaderboard? A place for fans to stand out in the community. The top 3 get special badges in the live chat. It resets every stream so you can always try again. How do you get on the leaderboard? You need to collect experience points or XP. You send live chat messages and you send super chats or super stickers. Okay, I am totally turning this off. This is awful. Okay, let me see how I turn this off. Really what I want is people posting as many comments as they can to try to, that just creates noise. Settings. Channel. All right, let me see what it. Sorry about this. This is terrible. Don't turn it off. All right. Fine. We'll leave it on. But if this devolves into madness, how can this not devolve into madness? Right? People are going to try to post as many short little quippy things as they can to be a number on the leaderboard. No, I'm absolutely turning this off. This is terrible. Okay, how do I turn this off? YouTube, privacy, live chat, leaderboard. So, community, no. Settings, privacy. There is no settings. Okay, it's there. There is no permissions? No. General? No. Moderation? No. No. Okay. Oh. So the documentation is incorrect. So it doesn't tell me how to turn this off. Settings, privacy, live chat section. So there is no privacy in the settings. Permissions? Nope. Channel? Nope. Feature eligibility? Nope. Great. This is going to be fun. Okay. All right. Well, then I'm going to just figure this out after the fact. Don't abuse this, please. Please. Seriously. Yeah. Okay. Remember your color chart here. Don't worry. I'll be okay. Okay. Let's start recording. Yes, I am recording. Yowza. Okay. Awesome. All right. Hey, thank you, everybody, for joining me on this early morning European time stream here of the Question Show. So, for those of you who have no idea what it is that you have stumbled into, this is going to be the live question show. This is the raw material, the grist for the mill that will then be turned into the weekly double question shows, as well as all the overtime segments that will keep you entertained during the summer hiatus. Summer hiatus, you say? What's that? New people will not realize that we don't do any live streams in July and August. So if you look at your watch, your clock, your calendar, it is June 2nd today. Happy birthday yesterday, Dad. Although I called you, you don't need to find out that I am, wishing you a happy birthday here on my live stream. Anyway, right. So we've got 3 more episodes to do after this. Let me count them. Today, June 9th, 16th, 23rd, and the 29th. So we have this plus 4 more. Or the 30th. So this plus 4 more. And then we go into the summer hiatus. Now, we're still producing all of the regular content. We still put out all the news. I'm still doing interviews. But the question shows, they come from overtime. In other words, we have banked up and we're ready to deploy a bunch of the questions that we didn't get to in our regular question shows that are still really good questions. And so we will roll those out over the course of the summer. So it'll feel like the channel is still going exactly as it is. The thing that won't be happening is the live stream. And actually we do that with Astronomy Cast as well. So, and that's a way that I can go away for more than a day or two and not have the entire cathedral collapse around me. So, but anyway, so this is the question show. We're going to go ahead and tackle your questions. Go ahead, put any questions that you have into the YouTube chat, the live stream chat. If you're watching this in the future, it's too late. You've already missed it unless you have a time machine. Right. And you will, we have a database and we will be slurping in the questions that you ask into the database. We've got our moderator, Zapfan's here. I'm assuming John Suffield is here. We will be able to pull those in, and then I will tackle those questions in whatever order I fancy. But I try to give emphasis to the people who've never had a question answered before. So if you've never had your question show up, there are some people who ask questions all the time, and it's great, and I love it, and thank you for participating. And I just hope you understand, right? Like, well, I'll try to get through all the people who've never had a question answered before first, or as best I can. And then usually sort of at that midway point, or as we're getting closer to the end, I will try to just go through everybody's questions. So for those of you, like Casey, you've got some great questions. Thank you. But, I hope you understand now, like you've got 6 that have been in the show. So they're there. I see them, and I will try to get to them, or as many of them as I can before the end of the episode. So I try to give emphasis to the people who never had a question answered before. Remember that I am just a journalist, not a scientist. And so if you want my opinion about some scientific theory, I don't have one. I can just tell you the sort of overall zeitgeist of what the scientists believe at this point. I cannot provide any additional information. That said, I will give my opinion, but I try to sort of stick to my lane about what I can and cannot give opinions about. I'm better at things like space policy and, being the publisher of a website and being a dad and running a Dungeons & Dragons campaign. So that's the kind of stuff that I can give you opinions about. But, if you want to know about the multiverse theory, I have no opinion. And then the third thing is that, we get a lot of questions. Hundreds of questions we'll pick up in this episode. We will... So we'll go through as many of them as we can, but I'm sort of thinking about the questions that we get a lot or the ones that we've answered recently. And so if it feels like, hey, I asked a really good zinger and Fraser hasn't gotten the question, it's possible that I just am avoiding it because we've just answered that question so many times. And so I may sort of near the end of the show give you like a really quick answer, which is like, we give this answer all the time and just do a search on the channel. But yeah, so like, don't take it personally. And then the other thing is like, I don't know the answers to everything, So if I just like don't know the answer, I'll just skip it. Now later on, we can do a little bit of research, and I can try to sort of synthesize what information I see on the internet to sort of give you a better informed answer. But yeah, like if it's just not like in the top of my head, I'll probably skip it. Now this live stream is going to last 2 hours, so it is currently 8:11. We're going to go until 10 o'clock Pacific time. Modify your time zone in your brain accordingly. I am a morning person, and I got 2 coffees in me, so I think this is going to be a lot of fun. All right, let's get into the questions. Oh, please just put your question in once. Don't put it in multiple times. The moderators see it. We got it. Frosty Winnipeg. When is Fraser getting an asteroid named after him? I already have an asteroid named after me, which is... Oh, thanks, old timer. The name of it is asteroid 158092 frasercain, and I have had the asteroid for more than a decade. So the asteroid... So, for those of you who don't understand how this works, when you discover an asteroid, you are able to give it a name. You can make a recommendation of a name to the International Astronomical Union. And they have various qualifications about the size that the names can be, and you can't use dirty words and all that kind of stuff. But you can name them after people. And so back about, like 15 years ago, there was an astronomer named Jeff Metcalf. And he was called the blue collar astronomer. And he was a sort of prolific asteroid hunter and named asteroids after a lot of people. And I got one, Derek Colanduno got one. So there's a bunch of them were given out. So it's early in the skeptic movement back in the sort of early 2000s. But there's been like a lot more asteroid hunters that have been naming a bunch after people recently. And so I know Anton Petrov just got an asteroid. So congratulations, Anton. And I know Brady Heron got one as well. Now Brady got the biggest one, and he just like lords it over all of us. But it's great. It's amazing. What an honor to have an asteroid named after you. Like, of all of the legacy, of all of the things, at some point in the far, far future, when humanity spreads out into the solar system and begins dismantling the solar system, at one point they will get to asteroid 158092 frasercain. They will dismantle it, and they'll pour one out, I hope, as they are tearing it apart to build their Dyson swarm. So yeah, thanks to Jeff Metcalf. Now the tragedy is that Jeff Metcalf died of cancer, like in his early 40s. So shortly after he was, giving this incredible gift to all of us science communicators, giving us asteroids, he passed away, and it really sucks. So, but yeah. So if you want to, participate in this process, get out there, discover asteroids, name them after people who you think should be remembered in history. And I can't believe one of them is me, but yeah, I have an asteroid named after me. Let me make sure that gets caught in the database. But Anton Petrov has a great video on his channel where he announces that he had an asteroid named after him, but also goes through why this happens and other people that are named after. So it's really cool. Jimmy D is hooking an asteroid named after me. I'd want my remains to be launched there. Yeah, that'd be awesome. Oh, there you go. So Becky Spear's got one. Yeah, there's a bunch. Rod Tolosa. Could there be life on Venus similar to life deep in our oceans? Wasn't phosphorus detected? So the detection that you're talking about was phosphine, which is a chemical that's here on Earth that's produced by bacteria. And astronomers think that they might have detected the presence of phosphine in the atmosphere of Venus. And so if bacteria on Earth produces it, then maybe bacteria on Venus is producing the phosphine. But there are probably inorganic ways that phosphine could be produced. So, this is a controversy in the astrobio community. Now, what you're talking about, though, is could there be life underground? Like the surface of Venus is more than 400 centigrade. Just choose a metal with a low melting point to compare it to. You could bake a pizza on Venus, But anyway, so the temperature on the surface is incredibly hot. But the question you're asking is, if you could just go down deeper into the surface, if you could go down deeper from the surface, then maybe you could have more reasonable temperatures. And the answer is no. It just gets hotter. So, here on Earth, at the center of the Earth, the temperature is like 6,000 Kelvin, which is the same temperature as the surface of the sun, roughly. And that as you get closer to the surface, then the temperature gets lower and lower. And eventually it is you reach the surface of planet Earth and the temperature is the average temperature of the planet. But wherever you go, if you go down, say, a kilometer or two, it heats up. And so at a certain point, I think it's about 6-7 kilometers down, it's the limit of what life can handle. But the temperature starts at the surface and then gets hotter as it goes down towards the core. And so the same thing is going to be happening on Venus, except the surface is already hotter than what bacteria can handle. And then it's just going to get hotter. So unfortunately, if you try to go deep underground on Venus, you wouldn't be able to find any viable life. You need a cooler temperature on the surface, and then it could get warm enough. Now, you could have that kind of a situation on other worlds where it is cold where it's exposed to space. Think about the moon, for example. People have proposed that there could be life on the moon, that on the surface of the moon, way too hot. But as you go down into the moon, the temperatures increase, and there could be some place where liquid water, there could be some place inside where the temperature reaches enough to make liquid water. And wherever we find liquid water on Earth, we find life. And so if there's liquid water inside the moon and maybe sources of chemicals that they could be using, then that could allow life to form. And you could imagine that going on across the entire solar system, the entire universe, wherever you have this boundary, really cold, hot interior planet, liquid or water present on the world, then there could be some zone where life could, find a way. Alan Gross, do all Canadians know how to build robotic arms? Man, we are so categorized. You can't put us in a box. We can build all kinds of limbs, wheels, legs. Liam Dobbin. Could the answer to dark matter be that between the stars, it's full of planetary systems with failed stars, like planets orbiting super Jupiters? So the ratio of regular matter to dark matter is 1 to 9. There's 10 times as much dark matter as there is regular matter in the universe. And the problem is with dark matter is that we can't see it. It doesn't give off any light. It doesn't seem to interact with regular matter. It doesn't seem to interact with itself. And so the problem is that if you propose any kind of regular matter, like stars, planets, gas, things that are just dark and we just can't see them, that can't provide the answer, because you would still be able to measure the places where this stuff is interacting. So for example, if you have two clouds of molecular gas that are completely dark, they're not giving off any illumination, they are cold, 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 and then they crash into each other, then the gas piles up and heats up and then puts out radiation, and we detect it. And so astronomers have done an amazing job of mapping out all of the places where all of the baryonic matter is, the regular matter, the gas, the dust, the planets, the dead stars, things like that. And it's only 1/10 of what you need. And so, what if the thing that is 10 times as much as the stuff we can see is also the stuff we can see, but we can't see it, then we would see it. And so the problem is that we don't see it. And so, so this was like the first thing that everybody thought of was like, wait a minute, what if it's just regular stuff, but we just can't see it because it's dark? And that theory was almost immediately turned out to be not true. And so they had to move on to more exotic possibilities for what dark matter might be. What is it? We don't know. Abstracted away, is there any effort to spot helium-rich dwarf stars as a technosignature? If any civilization achieves star lifting, that would be a way to see it, right? That's an interesting idea, and I have no idea. I just wanted to sort of like put a pin in that and think about it. So thank you. So what this means is that I do a review after I complete every question show, and I go through every question that I answered and think about whether I did a good job of answering the question, or look at the questions that I avoided because I didn't know the answer, and then I research the answers, and then I put them into my Anki to be better next time. So yeah, that's a really cool question. It's very interesting. Maybe I will check the literature and see if anybody's ever done that, because it's a clever idea. Angus Campbell, could a giant meteor knock the moon out of orbit? Sure, if it was a giant enough meteor, like a meteor the size of a dwarf planet. So, the moon, like if you smashed the moon with a really large meteor, say something that is, I don't know, 1,000 kilometers across, like something really big, like one of the biggest asteroids. I think Sirius is only like a few hundred kilometers across. So you would have to take something enormous and smash it into the moon. And that would change its orbit. It'd be a one-time change to the moon's orbit. And so after everything had settled and the moon had been turned into a mist of material, and that mist had congealed again back into a spherical world, it would have a new orbit based on the sort of combined vectors of the two objects as they came together. And now you have the moon in a new orbit. And like, obviously we see objects in non-spherical orbits across the entire solar system. The Earth is in an elliptical orbit around the sun. The moon is in an elliptical orbit around the Earth. The inclination of the moon's orbit is not the same as the Earth's inclination to the sun. It's like 5 degrees off. And so all of these little tiny tweaks across the entire solar system, they can be the result of impacts, but they're also can just be the result of gravitational interactions between planets. As Jupiter is sort of gets to its closest point, Earth, on its orbit, it pulls a bit at the moon, and the Earth tries to pull a bit at the moon, and the orbit of the moon tweaks a little bit, and over billions of years, these little tweaks add up, and we end up with the solar system that we have today. But, impacts are definitely one way that you could do it, but we don't know of any objects now that are floating around in a dangerous orbit that could cause this. Silas Marshall, did you get any auroras last night? Too high smoke level in Minnesota. So we did. It was like, so the auroras went off at like 3 a.m, and I got up and I went outside and I looked at them, and they were, they were there, but they weren't great. And as an aurora connoisseur, wake me up when it's like green curtains in the sky. I could see this brightening towards the north, and then I took out my phone and took a long exposure picture, and I could see some aurora activity. There was like a little bit of green and a little bit of purple in the sky, but no, that's like, so we've seen this a lot, and especially, as we're in solar maximum right now. And so I was like, meh, and went back to bed. But you always have to check. And so we have, my wife especially is the aurora hunter of the house, and so she keeps track of the aurora activity. And every night that we're expected to get a high KP level, we go outside at the predicted time, even if we're asleep, and go and just check and see how it looks. Sometimes we take turns. It's like when you've got like a little baby and like the kid's crying, and it's like someone's turn to go check the baby. But it's like someone go check the auroras and then report back. And every now and then they're great, and then we both get up and we bundle up and sit outside and watch the auroras. So last night wasn't that great for us. Nathan Cletus, is there any evidence to show if the universe is rotating? And if that's the case, wouldn't that mean that there's an axis or point around which the universe rotates? So I'm going to direct you to a recent video by Dr. Becky. She sort of covered this research, and then in a later short, she sort of responds to the exact question that you're asking, which is, if astronomers think that the universe might be rotating. This is like, okay, all right, let me do a better job of this. So this is based on a recent report where a team of astronomers proposed that the reason we have the Hubble tension, the difference in the measurement of the expansion rate of the universe from a more sort of recent past area around us to the cosmic microwave background radiation, is that in fact the entire universe is rotating. And so that would add an outward acceleration to objects that are the farthest away from us, and then that would partially or maybe even fully explain this Hubble tension. And once you say, well, if the entire universe is rotating, then you've got to say sort of like rotating around what? What does it even mean for an entire universe to rotate? What if the universe is infinite? What does that mean? And in fact, the astronomers propose that it takes like 500 billion years for the universe to fully rotate once. Again, what does that mean? So, I'm not going to answer your question, unfortunately, but I'm going to direct you to Dr. Becky's video. So she did a recent coverage of this, and then she also posted a short where she answered this exact question. And the gist, if I remember her answer, is that it's sort of like, there is no reference point. That, if the universe is finite, then there still is no center of the universe. And so it's always based on your perspective where you are, what you see is rotating. But definitely check out her videos and her short to find out a better answer. Lamabot, can anyone ask questions? Yes. Anyone can ask questions. Rick W., will the new ion engine be tested to travel in deep space and return in the upcoming years? I'm not sure which ion engine you're talking about. There are many spacecraft that have used ion engines traveling through the solar system. Some have done flybys of Earth. Like, I think some of the Japanese spacecraft sample return missions use an ion engine. So ion engines, all of the Starlinks use ion engines. So this is a very common technology. What? Max Payne, do we live in a black hole that exists within another universe? We get this question a lot. So, do we live in a black hole? There are some astronomers who have proposed, cosmologists who propose that the entire universe is inside of a black hole, because there's sort of some interesting coincidences about black holes and the entire observable universe. That said, it is definitely not the mainstream view, and there's no evidence that this is true. Yes, but do any have twin ion engines? Adam Redwine, do ion engines always use xenon? No, some use krypton. Peter, this show sucks. No, no problem. But I mean, it sucks. What sucks is that you're forced to watch it, right? Like you're here, you have so many things that you could be doing, and yet, by law, you're stuck watching this show. I'm sorry. I wish it could be another way. I wish there was like a vast list of things out there that you could spend your time with, but you're stuck here with me for 2 hours. Ask a cool question, Peter, about space, and I will be glad to answer it. Noah Ciclari, Apophis is due to pass by Earth very close in 2029. What would be the best country to view it from? I don't remember what the view track is. I'm sorry. It's a great question, though. Your average Terraria player. I've always had trouble understanding breaking light speed causes time paradoxes. And Googling says it's not really true except for distant observers. Is that true? I mean, what it is that if you can calculate the time dilation that a traveler who is moving close to the speed of light would experience based on their speed. And so you take the person's speed, you punch it into this equation, and then that will let you calculate the amount of time dilation that they experience compared to a different observer. The problem is that if you put in a number that is greater than the speed of light for their velocity, then you get a negative amount of time dilation. They experience negative time. They go backwards in time. Now, you can't go faster than the speed of light. So having the equation give you that weird outcome doesn't mean that actually happens. It just means that this equation is not able to handle what happens if you go faster than the speed of light. And it's, there doesn't seem to be any reason why you could go faster than the speed of light. Nobody has any idea how that could happen. And so it could very well be is almost certainly just impossible according to the laws of the universe. Trinidad. Fraser, I'm curious if you can explain to me about gravitational lensing. What are the requirements? Like how far does the first object need to be and how much gravity does the observing object need? So gravitational lensing works when you've got a foreground object, a galaxy cluster, a star, a black hole, and then you have a background object, another galaxy, another star, a planet, whatever. And then you as the observer, you are perfectly lined up so that you've got the gravitational lens, and then you have the object that is being lensed. And there's a ton of parameters, but the key is that they need to line up very well. When I say very well, it sort of depends on the lens. If it's a star, then the lineup needs to be really perfect. U, star, target. But if it's a galaxy cluster, the lens can be kind of messy. U, cluster, stuff on the other side of it that looks into these, becomes these crazy arcs around the gravitational lens. But the key is that the gravity, you want more gravity, more better. And so, we talk about this idea of using the solar gravitational lens here in the solar system to be able to observe exoplanets with high resolution. In this case, you need to go out to the solar gravitational lens, which is more than 550 astronomical units away from the sun. And when you get to that point, then you are far enough away that the gravity of the sun is focusing the light like a telescope, and you are at the focal point, and you are then looking at whatever is exactly on the opposite side of the sun from us. And it can be far away. Like, it doesn't matter. The distance doesn't really matter at this point, as long as you're at the focal point. It's kind of the same as you, like, using a telescope. You move the focal point of the telescope back and forth with inside the telescope, and that focuses the light of distant objects that you can see through the lens. So the thing that matters is that more gravity, more better. And so people always suggest, could you use Jupiter as a gravitational lens. And theoretically, sure, you just have to go much, much farther away. That if we had a black hole with 10 times the mass of the sun here in the solar system, then the black hole gravitational lens would be a lot closer. So there's a lot of factors that go into it. And, they're very useful because they provide these natural telescopes. If you want to observe the most distant galaxies, the earliest times in the universe, you've got to use the additional magnifying power that comes from these gravitational lenses to look even farther back. They can take what would be, almost impossible even for James Webb to see and become a galaxy that can be easily studied by James Webb. So, gravitational lenses are vital for astronomy, especially if you want to see stuff that's at the very limits. There's a lot of other cool stuff they do with gravitational lenses, discovering exoplanets, finding, potentially, counting how many rogue planets there are out there in the Milky Way, searching for potential primordial black holes. So they're have become just this incredible tool for astronomy. Annie Alexander, how powerful would a telescope have to be to see the Oort cloud? It would have to be very powerful, ridiculously powerful, so much more powerful than the telescopes that we have today. When you think about the Oort cloud, these are objects that are potentially thousands of astronomical units away from us, to tens of thousands of astronomical units away from us. We can just barely see objects like dwarf planets that are hundreds of astronomical units, objects that are, 500 kilometers across at 200 astronomical units. That's like the very limit of what our telescopes can see. So to see an object that is 10,000 astronomical units away, that's only 10 kilometers across, like a average size comet, that is so far beyond our capability. If we use the solar gravitational lens, maybe we could do it, but you need to know where to look. And the problem is that the spaces in between the comets that far out are huge, and so you just don't know where to look. And so unfortunately, we will not be able to find, directly observe objects out in the Oort cloud until they start to fall in and they become comets. So it's really, really tricky. There's like 10 to 100 trillion, no, is that right? 10 to 100 trillion objects larger than 1 kilometer across in the Oort cloud. And yet they're, in many cases, an astronomical unit apart from each other because space is so big out there. I mean, space is so big everywhere. Clint Davis. So you know how planets are located around red dwarf stars that are mostly all tidally locked. Are there any ideas to give a planet an artificial spin? I mean, you could give a planet an artificial spin. You smash it with an asteroid, and that will give it a spin, and then the planet will start to turn. But then the very forces that put the planet into a tidal locking are going to continue on. And so its spin rate is going to slow down, and eventually it will lock to the star again. It is inevitable. It's inexorable. And so, like I'm sure there is a rate that you could smash asteroids into your planet to keep the spin rate up. And, maybe there's less devastating ways to do it. Like instead of actually crashing asteroids, do close flybys and use, the interaction of the gravity between the asteroid and your planet to try and pull it off of its spin. But really, practically, no, you're stuck with a tidally locked planet around a red dwarf star. Jack Woodward, how big of a volume of space do we need to search before we could say with 99% certainty that we are alone in the universe, at least for now? I don't know the exact math, but this is sort of a conversation that I had with one of the designers of the LUVOIR telescope. This was the predecessor to what is going to become the Habitable Worlds Observatory. And he was saying that LUVOIR, which was going to be like a 15 to 20 meter telescope, like a true successor to the Hubble Space Telescope, it would have the capability of measuring the atmospheres of exoplanets with such precision that you could be able to tell whether or not they're inhabited or not, that if there's any kind of life. And that he said that the power of LUVOIR would allow you to rule out life in the observable universe to about 99%. In other words, that LUVOIR would be so capable of examining exoplanets orbiting around stars to a large enough volume of space around us, and if it doesn't find a hint of a biosignature around any of those stars, then you can extrapolate that observation to the rest of the universe. Like, assuming we're not in a special place in the universe, that whatever is around Earth, out to 100 light years or out to 200 light years is what you're going to find out there in the rest of the universe, then that tells you that we're almost certainly alone in the universe. And so it really just depends on the power of the telescope. When the real Habitable Worlds telescope comes online, it's not going to be as capable as that original plan of LUVOIR. Maybe it can only see in a radius to 20 light years around us. And so you'll get a smaller number. Maybe you're at 95% predicting that we're alone in the universe. But it's really kind of amazing that that we are right around the corner from developing telescopes. Like, if we really wanted to, if there was a budget and the incentive to answer this question once and for all, we could do it. This is, $20 billion. We could build a telescope that would give us a pretty definitive answer to the question, are we alone in the universe? The question is just, does anybody have the will to build a telescope that big? Because it's, these telescopes take longer than expected. The technical risk involved is huge, but I hope that we will get an answer either way. We will either find out that we aren't alone in the universe. We will go like, oh, you look at that star over there. We know that we have detected biosignatures in the atmosphere of a planet orbiting around that star. That would be mind-bending, wouldn't it? Or to look out into the cosmos and say, to the best that we can tell, we are completely alone. And because we're alone, then the future of life in the universe depends on us. That the choices that we make about how we protect our planet or fail to do so, how we invest in space exploration to get ourselves off of this planet and potentially go to other star systems, nobody else is going to do this. Nobody's coming to save us. It's on us. And hopefully that would make us take our environment more seriously and would give us more incentive to get better at space exploration. That would be my hope. And so I think, it's funny, if you give people an envelope and inside that envelope is the answer to the question, are we alone in the universe? Would they want to open the envelope and find out the answer? I think most people would. They'd be curious. But if you did find out the answer, what are your responsibilities if you know the truth, the terrible, terrible truth, right? That if we are alone in the universe, then that has implications for what the future of humanity means. And if we aren't alone in the universe, that also has implications for the future of humanity. Andreas Lusty. Hey, Fraser, I always wondered if it's always you who reaches out to interview candidates, or are serious researchers already queuing up to get an interview slot with you? It's always me. It is 99% me. And the way this works is I go through my review of all of the literature every day. So I go through all of the journals, all of the press releases, all the research that's coming out from NASA, and I have this sort of list in my brain of stuff that I feel I don't know as well as I would like to, or stuff that I'm curious about. And then if a piece of research matches that squishy list in my brain, then I'll go, I'm going to try and interview this person. And then I do a bit of research, find out who they are, find out their email, send them an email. Hi, I'm Fraser Cain. I'm the publisher of Universe Today. I saw your recent journal article about using electrostatic surfaces to repel Martian regolith, and I was wondering if you would be available for an interview on my YouTube channel. Here's my YouTube channel. Let me know if you'd be interested, and I will give you a link to my calendar to set a time that works for you. That's the gist of the email that I send out. And I get about a 50% hit rate on that email that I send out. In some cases, it has to go through the press officer for the institution. If it's in really extreme cases, like NASA, they will sometimes want to have a press officer sitting in the conversation while I conduct the interview. Yeah, and then I get the interview, and then so no, And you know, interviews do come in other ways. So I will get like an inquiry from a publicist when there's a new book. So, which is, you know, great. Like, for example, I interviewed Eric Berger. He is one of my favorite space journalists, and he had recently written a book about SpaceX. And so his publicist reached out to me and said, hey, do you want to interview Eric Berger? I'm like, yes, please. And so I responded back and said, yeah, I'd be glad to interview him. And like, that's a great time. You know, people who I find are difficult to interview, but if they write a book and they're promoting it, then they're open to interviews. Not that Eric Berger has ever been a problem to interview. He's a star, but you know, if you want somebody who is maybe more difficult to interview, you know, some of the biggest celebrities I've interviewed have come through that process. And then there's been occasionally, and you will see some of these interviews here on the channel, someone who is working on something and is a fan of the channel. Will, you know, they go, you know what, the work I'm doing is interesting enough. I'm going to reach out to Fraser and see if he'd be willing to do an interview about it. And that's great. I love that because they know the format. They know the kinds of questions that I ask. They understand what my level of technical ability is and the kind, you know, they know where I'll try and set the interview level at. And often those go very well. You know, I'll do some vetting to make sure they are who they say they are, and I look at their research and get a sense of what the story I think is, and we'll conduct the interview. But I would say it is 95% of the interviews are me cold calling researchers based on work that they've done, and so and in many cases it's their first interview. They've never been interviewed before because nobody has ever bothered to reach out to them because everybody wants to talk to, I don't know, Bill Nye. Parth Shah, how has your experience been with the Seastar S50? It's great. I love it. Of course, I live on the west coast of Canada, and we get a lot of cloudy days. And so when I first bought it, of course, I summoned the clouds. But then within a couple of days, we got a nice run of about 4 or 5 days of clear nights that lined up with a new moon. And so I was able to put it through its paces and take some really great pictures. I'm really pleased with how it turned out. Then we got about a straight month of bad weather clouds, and it's finally clearing up. So we had some clear nights in the last couple of nights, and so I'm taking the Seastar back out. But it works perfectly for the way I need to be able to do astronomy, because I'm not a night person, and so I have a really hard time staying up late. But instead, I take the Seastar, I check the weather forecast, take the Seastar, put it outside, give it its plan for the night, come back in the morning, harvest the pictures that were taken, and I really enjoy that. So it's like, I highly recommend this telescope. Just as a, like, if you know what it does and you know what you're getting out of it, like, if someone says, oh, you've got a telescope, can I see Saturn? And you're like, oh, no, I can't show you Saturn. Like, I can show you this teeny tiny little blob that you're gonna have to imagine is Saturn, but that's what the Dobsonian's for. That's what a nice spotting scope is for. But what the Seastar lets you do is take long exposure pictures of the night sky at a reasonable price with minimal fuss and setting up and so on. No, it's, obviously these little smart telescopes are the future. And the problem has always been that the current offerings are too expensive. They're in the $5,000 range, and the C star is in the $500 range, and the C star S30 is even cheaper. And I can imagine that eventually these things will be in the $100 range. So we're getting there. Peter, if our simulator is in 2D but being rendered in 3D, does that mean that the flat earthers are technically correct? Right. So if the universe is a simulation, then the simulation is going to be stored in some kind of memory. And the kind of memory would be like we don't even know. Like it's going to be more advanced than any memory that we use. But currently our memory is stored in things like hard drives. And those are two-dimensional, ones and zeros in big circles on hard drives. Now they will have multiple platters, so they can have multiple layers, but each one of them is flat. So technically, excuse me. So technically, yeah. You know, if the universe is a simulation and the simulation is running on hard drives as we understand them correctly, then everything is actually two-dimensional in terms of ones and zeros. And then, you know, you can imagine the sort of matrix multiplication math to turn, you know, three-dimensional objects into something that you can view with your eyeballs for the perspective of each person that lives in the simulation. But, you know, the problem, of course, is that we can't know whether or not we're living in a simulation. And so that part doesn't matter. But, you know, the shape of the Earth in the simulation is going to be an oblate spheroid. So while the shape of a piece of paper is going to be a plane. So I think technically, no, it's not. Correctimus. What is the likelihood that a rogue planet is passing through the Oort cloud right this moment? I don't know what the likelihood is. And, you know, but the Oort cloud is gigantic. That the Oort cloud stretches out pretty much halfway between us and Alpha Centauri. And Alpha Centauri's Oort cloud stretches probably halfway between us and them. And so the Oort clouds of Alpha Centauri and the solar system are pretty close to overlapping. And when you imagine sort of the average density of stars in the Milky Way, they're all kind of almost overlapping. And then if there are truly 10 times as many rogue planets as there are regular planets if there truly are 10 times as many rogue planets as there are regular planets in the Milky Way, then they're everywhere. And they're constantly passing through various Oort clouds. And if they are, then they're going to be influencing with their gravity the objects in the Oort cloud. And that could be the source of long period comets, that the gravity of the object is passing through the Oort cloud, throwing objects inward, and that's how we get them. You know, astronomers have done plenty of simulations and calculations of when various stars get too close to each other, and they find it does happen on a regular basis. You know, it sort of depends. You know, every million years or so, you will get a star, like a full star, pass through the Oort cloud, and like that's got to cause disruptions to the Oort cloud. But rogue planets are happening probably more often. You know, there are probably tens of thousands of interstellar objects, Oumuamuas and Borisovs, passing through the solar system right now at various places. Some deep in the solar system, most out in the Oort cloud. It's happening all the time, that we have all of these interactions between all of the star systems. Nobody lives in a bubble. You keep saying invisible entities, please, Peter. I don't know what you're talking about. I don't know what invisible entities are. By definition, they're invisible. Tyler, does a space probe have to cost millions or billions of dollars to gather extremely valuable data? Have we ever sent a swarm of cheaper probes out into deep space on a single mission? So spacecraft can cost all kinds of things, from tens of thousands of dollars, little CubeSats, to millions to billions of dollars, depending on the size, the mass, the complexity, the amount of scientific instruments that are built into it. On the expensive end, we have something like, say, the James Webb Space Telescope, which is like one of the largest satellites that's ever been launched. Took one of the most powerful rockets to launch it, and the thing cost $10 billion. It took 20 years to build. But on the other hand, there are CubeSats. There are these tiny little satellites that weigh just a couple of 100 grams, and they can be built by a university, and they can be tucked into small areas inside larger rockets that can be launched as part of the launch. And the launch costs of that are very inexpensive. And so there are people probably watching this right now who are at a university, and their university is working on a CubeSat, and these CubeSats can do incredibly valuable science. They have, you can put cameras on them. You can put instruments that can measure in various wavelengths. You can have little telescopes on these CubeSats. And so, depending on the scientific question that you're trying to answer, you launch the satellite that you need to build. And for some, it has to be this giant flagship. But often, if it's easier to use a smaller one, then you can. And a lot of the times, these CubeSats are used to test out ideas. So, for you to be able to get a mission launched, a big flagship that's going to use some new piece of technology, you have to decrease the technical risk on your mission. So you have to take what is something that's never been flown in space before, and you build it into a CubeSat, and then you launch it for, say, $1 million. You test to make sure that this technology works and it does what you're looking for, and proves, it's a pathfinder that proves that your ideas work, and you have then reduced the technical risk. You can then build that instrument into your $1 billion spacecraft, and everybody thinks that you're not being overly risky. So no, we're at this age now, thanks to miniaturization, thanks to decreased launch costs, that you could probably put a CubeSat into orbit for $100,000 all in. The thing would weigh 100 grams, and it would be a fraction of a couple of centimeters across, and yet, you probably could do it. Hannah Sketz, what's the best way to ask Fraser these questions? Here in the chat or email? Definitely not email. Here in the chat. So I have 92 questions in the queue right now. So I apologize that I haven't gotten to your question yet. I'm trying to give emphasis to people who've never had their question answered before. And then I will, probably in about 10, 15 minutes, just switch into hammering out answers to questions as quickly as I can. Something personal that's just, I'm trying to give the best answer, and the laws of time and space are our constraints. Maciej Jerkowski, how long do we search for dark matter until we just admit that it really is a particle that is not interacting at all except via gravity? I don't know if anyone would ever say, okay, we just have to admit that it's a particle that is not interacting except by gravity, because that, as long as you don't know what it is, then there are still various possible theories that could explain what dark matter is. Like, all we have are the collection of observations that galaxies are rotating in strange ways that don't match the way you would expect the stars in a galaxy to rotate, that galaxies should be tearing themselves apart the way they rotate, that we see gravitational lensing at the largest scales when there seems to be nothing there that is actually producing the gravity that's causing the lensing, and that we can measure the ratios of matter to other things in the early universe and the cosmic microwave background radiation, and that these and other observations build together to create this case that there is more to the universe than we can see. That is dark matter. Dark matter is the collection of observations that have been made that the universe behaves in ways that our current laws of physics, as we understand, don't predict. That's it. That's the beginning and the end. Now, obviously, when you say, like, we've got a mystery in our hands, the universe is not behaving the way we expect, the first thing to say is, well, maybe we don't understand how the universe should be behaving. Like, obviously. And so there are certain theories for dark matter that say we don't understand how the universe is actually supposed to work, only what we think it's supposed to work. And that's like one group of theories to explain it. Another one is like maybe there are invisible particles that we can't see, and that would explain it. And like, that's another one. Or maybe our measurements are off, and that's another possibility. And so I don't think, like, until somebody like actually produces dark matter particles in a particle accelerator like CERN, or makes an observation where they can detect the particles interacting in a way that really is a smoking gun to say, okay, yes, fine, it is particles that is causing dark matter, then the controversy will never end, because it won't be a completely satisfying answer for the entire scientific community. You're always going to have factions. One group says it's got to be this, one group says it's got to be that, and neither has enough evidence to make a compelling case that everybody will agree on. But we see this all the time, right? This is science, that there are various states of scientific theories, from I've got a rough guess to the theory of evolution, right? That is well established with hundreds of lines of evidence that nobody who understands the current level of the science would have questions about the main ideas, and is then going to be arguing about different parts of it. So dark matter is just earlier on that process to go from collection of observations to a comprehensive theory that helps us understand it. And until we get to comprehensive theory, then it's really open season for everybody. Old timer, I want to see a Fraser live stream of him building Lego. No thanks. I could do it like a live stream of me cutting trees down, cutting, clearing brush, of harvesting blueberries from the forest. Kenji, I just want to know the truth about the pyramids and why they line them up with certain stars. Because ancient people were incredible astronomers, that they deeply understood the motions of the stars in the sky. And it was a trivial task for them to line up the positions of objects on the surface of the earth with the things they saw in the sky. Stonehenge, I don't know if the pyramids are truly lined up to match, what is it, Orion's belt or something like that, but there's way better observations. My favorite of this is actually Hipparchus, who is the grandfather of measuring the positions of the stars in the sky, and he produced this first incredibly accurate catalog of all of the stars in the sky. He did like 850 stars in his original catalog, the brightest stars that you could see, and he believed, or other astronomers at the time thought, that maybe the Earth orbited around the sun, and that they knew that if the Earth did orbit around the sun, then you would end up with a parallax where the stars would change their position in the sky depending on whether the Earth was to the on one side of the sun or the other side of the sun. And so they tried to do the math, to do the geometry, to figure out whether or not the stars were bouncing back and forth. But they only had their eyes. They had these tiny little sighting tubes that they would use to measure the positions of the stars. They didn't have a telescope at the time. And so they weren't able to gather enough evidence to know definitively that the sun is the center of the universe and not the Earth is the center of the universe. And so they went with the Earth is the center of the universe because they couldn't see the parallax. That's how good they were at knowing the positions of the stars. They would measure the positions of the stars to know when to plant, when to harvest, various, when the raining season would begin, to when to do their ritual sacrifices. Ancient astronomers were just like us, in terms of like intellectual capability. They just didn't have necessarily the same kinds of tools, and they didn't have the same kinds of understandings. But boy, could they be observational astronomers, and did an incredible job. So, to line up the positions of buildings to, centimeter accuracy based on what you see in the sky is trivial for someone who is, really dedicates their life to observing the sky. Jacob Polasek, what are the most interesting citizen science projects in the astronomy space field right now? There's a lot of great citizen science projects. There's the Galaxy Zoo group. Well, they've got a Zooniverse. That's right. There's the Zooniverse, where they've got a bunch of projects where people can go and get involved in them. There's the work that we do at CosmoQuest, which is led by my Astronomy Cast co-host. I know we've got a new project that's coming out pretty soon. I forget what it's about. And then there's like ongoing various citizen science projects, people who are helping to confirm exoplanets, variable star astronomers, people who are looking through data from NASA telescopes to discover comets that are grazing the sun. So there's all kinds of ongoing work that citizen scientists can get involved in. Okay. Osiris MPG. Could a ship traveling to Alpha Centauri crash directly into a black hole the size of a few meters? How would such a collision unfold? How fast would it happen? Would the astronauts feel, if anything at all? So if a spacecraft hit a black hole that was a few meters across, then that would mean you have the mass of like Jupiter. I'm trying to think. So if you had a black hole the mass of the Earth, it would be a centimeter across. And if you had a black hole the mass of the sun, it would be a kilometer across. So I'm sort of imagining something a few meters across, you're having the mass of Jupiter. And so if you crashed a spacecraft into Jupiter, it would be catastrophic for the spacecraft. So yeah, it would, the gravity of the impact would dismantle the spacecraft very quickly. Now you could hit something with, say, the mass of an asteroid and it would just pass right through, punch a nice little hole because the gravity wouldn't be strong enough to really cause any failure to the superstructure of your spacecraft. But if you're going to hit the mass of Jupiter, it's going to, unless you're, made of some kind of unobtainium, it's going to cause stress to the structural elements of your spacecraft. In other words, dismantle it. Lamabot. Could it be that what we experience as dark matter isn't really something inside our universe, but some hypergravitational influence from other universes pulling on ours? Sure. Yeah, people have proposed that. You just need to gather evidence. You need to say, okay, like, how would some other universe's gravity pulling on our universe manifest? What observations could you make that would validate this hypothesis? And then you go out and you would make these predictions for what you would expect to see, and then you would make your observations, and you would confirm that the observations that you've predicted are correct. And then you would also try to make some unique hypotheses, some other observations that if astronomers go out to see, they should expect to see it. It would be great if you could answer some other unsolved questions about cosmology at the same time. The better your hypothesis, the better your predictions match the observations, the more likely it is for the astronomical community to accept this theory that another dimension is affecting the Earth with its gravity. Or affecting the universe with its gravity. And this has been proposed. You know, one of the weird things about gravity is that it seems to be a lot weaker than the other forces. And one possibility has been proposed that in fact it's because gravity is leaking into our universe from other universes. But again, you know, make the observations to validate the theory. That's where the rubber hits the road. It's like, what if it's like, you know, we're in a simulation, man. What if it's like another universe? What if it's great? You know, great theory. Now, make the predictions. Make your observations. Have your observations match the predictions. Anybody can then make sure that anybody can make the observations that match your predictions. Make predictions for future. This is what Einstein did. Einstein was like, what if it's not this Newtonian universe the way we think? What if, in fact, space-time is distorted and they're one and the same? And here's some math that explains all of the Newtonian motion that we see, but also there's this mystery of why the position of Mercury is always a little funny. My math predicts why Mercury is why it is. And also, if you go out in the universe and you see this thing, like for example, black holes crashing into each other, you should be able to detect gravitational waves coming from this thing. And people are still confirming the predictions made by Einstein. Now that's how you do it. Gold star. Tyler Reeves, kind of off topic, but I know you enjoy backpacking with nice gear. I know the hobbies don't exactly align for weight reasons, but do you ever wish for an ultralight takedown telescope to exist? I would never take a telescope on an ultralight backpacking trip. You know, partly because where I live, you don't have to go very far to get really dark skies. So I live in, like, my backyard is Bortle 3 skies, which it's funny. I was watching a video by Trevor from Astro Backyard, and he's like, I drove an hour to get to Bortle 4 skies because he lives in light polluted Canada. And I'm like, oh, dude, I just walk out my back door and I have Bortle 3 skies because I live on the West Coast and we are less populated out here, and I live in the mountains, and so my skies are pretty good. And I can get to Bortle 2 skies and even Bortle 1 skies with a short drive. And so with a car, and you take up the telescope and you sit under the skies and you really enjoy yourself. I can't imagine a need to take a telescope with me. You know, binoculars maybe, but it's a completely different, like, I'm doing astronomy with my meat telescope on my face when I'm in the forest, when I'm, you know, on a multi-day backpacking trip. I'm not going to carry gear. You know, when you're cutting the handle off your toothbrush, you are not thinking about bringing anything extra. But man, I love hiking. I'm training right now to get myself ready. I go and climb up I live at the bottom of a mountain, and so once a week I climb the mountain for about 10K and then come back home just to make sure that because like whenever you hike, you sort of are soft over the rest of the year. And then when the hiking season comes, you do your first hike and you're like, oh, my body is in so much pain. And so I'm like determined to not be in pain, for it to be easy. If you just hike, I'm like, yeah, this is what I do all the time. Snellwick. What is the coolest object you've ever personally seen through a telescope? I mean, my favorite object to look through a telescope is Saturn. that there's no better experience. You look through the telescope, you're looking at Saturn, you see the rings, your mind is blown. And you show this to anybody, and they're like, "That's Saturn. This is crazy. I just want to be an astronomer." Yeah, we all do, right? Like this. Like if you want to turn a person into a space nerd, you just have them look at Saturn through a telescope, and then they're off buying their own telescope. But I would say the most interesting stuff that we've seen, and not something that I've seen through a telescope, but when we used to do the virtual star parties, we had a couple of events that happened that were really interesting. One was that we were observing galaxies, and we were looking at M82, I think, Bode's galaxy. And one of the people who was in the chat, was it David Dunn? Anyway, one of the people was saying, "Oh yeah, Bode's galaxy, this is a galaxy that's well known for having supernova." And he goes, "But there's not one in there right now." And we were like, "Yeah, of course not." Turns out the next morning we discovered that a supernova had been discovered in that galaxy, and the picture that we took of that galaxy that night had the supernova. And if we had reported it, we would have shared in the discovery of the supernova. Like we saw the supernova as soon as anybody else did. We literally discovered a supernova while we were doing the show, and none of us were smart enough to realize. And Dave Dickinson, who's one of the writers at Universe Today, after that happened, he was like determined, like from this point on, I'm going to memorize the star pattern in all of the galaxies, so this will never happen to me again. Because he just was beating himself up. He still, to this day, beats himself up that he failed to notice the supernova that was going off in the galaxy that we were looking at. And then the other thing is that there was a lunar eclipse that we were observing, and this was something I was doing with Corey Schmidt, and so he had this live view of the moon, and we were chatting, and then after the live stream of the eclipse was over, I saw in the news that an object crashed into the moon and caused a little flash on the moon. And I'm like, did we observe that? And so I went back and scrubbed through the video that we took to the exact point where the collision happened. And yes, indeed, we had this little white spot on the moon when that thing happened, in exactly the right spot. And so, those are a couple of things. And it just shows you, like, it's not like I don't spend a lot of time observing things that I think people believe that astronomers are completely in control and they know exactly what's going on in the universe. But the reality is they don't. That amateurs go out and they look through galaxies and they find supernova, that people are finding asteroids all the time, that so much of the universe is happening that we have no idea. And that's why I'm so excited, like at the heart of it, why I'm so excited about Vera Rubin is that we will finally have this comprehensive system that is scanning the sky and looking for the things that are happening when we weren't looking. That before, it was always sort of serendipity that you would find these things. And now someone is going to look, okay, I got it. I'll watch everything all the time. And hopefully we'll find all that stuff. John Ulrich, with the recent changes to NASA's administration direction, what is the outlook from your perspective? Good or bad for NASA in science? Good or bad for NASA in general, science in general, Artemis, etc. So the news is breaking now that it looks like, man, what's his name? Anyway, it looks like, man, what's the name of the NASA? Oh my God, I can't believe I don't have his name. Jared Isaacman. Yeah, okay. So the news is breaking that the White House has decided to pull their nomination of Jared Isaacman for the new NASA administrator. And this was the person that was recommended by Elon Musk. And, of all of the various people who have been suggested as various parts of the administration, Jared Isaacman was seen as a bit of a mystery, that, he has flown to space, has helped organize several Polaris missions, is a giant space nerd, and believes in climate change, and seems to have a fairly grounded, rational position about NASA's role in space. Now it's sort of pushed by various his interactions with Elon Musk, like let's go to Mars, and so I think he was going to get on board with the let's go to Mars instead of the moon. But it looks like, he's disagreeing with the administration, and so they pulled his nomination. And so what that means is that they're going to find somebody who is going to do exactly what they say. It isn't going to push back, isn't going to say, well, wait a minute, climate change is a thing, right? Like it's a bad idea for us to cancel all of our climate change satellites into the future. So I think, unfortunately, when you have a person who is willing to stand up to authority, that's a good thing. You want that. You want somebody who isn't going to be your yes man. And so it felt to me that he would probably be okay. He lacked government experience, administration experience. He, lacked the kind of traditional NASA administrator experience that you see, the people who are the political, the bureaucrats, the lifelong bureaucrats who rose up through the administration, that he kind of came out of left field. But it, didn't feel like it was necessarily a big problem. And he didn't really say things that I could see that disqualified him to do this job. Purely lacked experience. Maybe was in the pocket of Elon Musk, maybe was in the pocket of other aerospace firms. So we would have to sort of see what actions and directions he would take. And if he's willing to disagree with the administration about certain things, for me, that's a good sign. Like you want, just in general, like, whether this administration specifically requires people to stand up against them, but just in general, you want people who are willing to sort of, speak to authority. So then obviously they're going to replace him with somebody who's going to do what they say, who's going to toe the line, who's going to implement without question the new NASA budget that's been proposed by the White House, the one that cuts 25% out of the NASA budget, that cancels a whole bunch of missions, that shortens the Artemis mission probably just to Artemis 3, which is the landing on the moon, and shifts the direction of the future of NASA to Mars. And it makes a bunch of requests for various hardware and stuff to be built, and yet doesn't necessarily request the kind of budget that's going to take to be able to do that. So I think that it's all a mess. Like you're kind of like, you're looking at a mess, a bunch of tangled spaghetti, and you go like, oh, is this, what kind of a house is this? You're already in a bad place. And it would be great to have the most qualified person who is best in the best candidate to run the administration, to run NASA, to be chosen, nominated, and have them get to work implementing what is the most logical policy with what they have to work with. But I don't feel like that's what we're going to get. But we don't know who the replacement name is going to be. So for now, NASA exists in limbo, although its budget is getting cut pretty dramatically. And that's kind of where we stand right now today. And from when I sort of think about it from my journalist perspective, the new official budget was released last week. So we're reporting that on Universe Today. Like, this is the new budget. These are the cuts. These are the programs that are getting cut. This is how these things are changing and how those things are changing. These are the things that are getting cut most deeply. These are the things that are not getting cut at all. Good news. It looks like Nancy Grace Roman isn't getting cut. Titan Dragonfly isn't getting cut. But Mars Sample Return Mission is getting cut. The Deep Space Gateway is getting cut. The entire NASA STEM outreach program is getting cut, which stings because, I think NASA does an amazing job of getting people excited and giving them good information about what they do. So that's the news. And then the other piece of news is that Jared Isaacman's nomination is being I guess withdrawn by the administration, and they're going to put up a new name, and we have no idea who that new name is going to be. But NASA needs leadership, and it's in a situation right now where it doesn't have leadership. So we'll have to wait and see what's going to happen. Man, so I think he rejected Isaacman to move to Katy Perry. Yeah, so I don't have any names. I don't have any recommendations that, it's not like I can't imagine people who would do a good job. I can imagine people who do a good job. And there are people who have already been NASA administrators who I thought did a good job. Jim Bridenstine was a surprisingly good NASA administrator. Came from a political side and yet got a bunch of stuff done. Others have been, mediocre. And I think there are people who would make great names, but like, that's not how this works. Right? The people who I think would make great NASA administrators would also be great because they would say no and they would push back against the administration. And then you know how that turns out. So for now, we're just going to let's just be reporters. Let's just be journalists. Let's just watch how this unfolds. Let's report on what happens. Let's account and provide a good, timeline for what happens. And then later on, people can assess whether or not things went well or poorly and refocus. JVGA17, is there anything novel or exciting to you happening with the upcoming Moonlander? I mean, right now, well, it's all novel, right? That you've got this Starship potentially is going to be a Moonlander. Is this the one you're talking about? Are you talking about a robotic one? You're probably talking about a robotic one. Which one? Sorry, I have to be more specific about the mission that you're talking about. So, the entire Artemis mission landers are interesting, novel, and apparently Blue Origin is making surprising headway and catching up to the lead that SpaceX had. So it could very well be that a Blue Origin lander goes to the moon first. And then there's like a whole bunch of landers, robotic landers, are going to be reaching the moon in, over the next couple of weeks and months. So there's a lot going on at the moon right now. Oh, the one landing on Saturday. It's the Japanese one, right? The Hakuto R, the re-Hakutoing. Uh, 410. Is there a difference between cosmologists and astronomers? Yeah, I mean, like, astronomers are sort of a more catch-all term. Astronomers are the people that are using telescopes to observe stars, galaxies, things like that. Cosmologists are generally thinking about the early times of the universe, the evolution of the universe, the formation of the universe, the large-scale structure of the universe. They're thinking more about the causes and the evolution of the universe over time, while astronomers could be looking at the sun, they could be looking at Alpha Centauri, they could be looking at a galaxy. So it's sort of, that's sort of the difference. Cosmologists are more theorists than astronomers are. Sid Remy, if I am on the ISS spacewalking and I want to deorbit some piece of equipment, what is the best direction to throw it so that it does not hit the ISS later and that it deorbits quickly? So if you want to lower the orbit of an object, you want to throw it you want to provide a thrust in the opposite direction that it is orbiting. And so in other words, if you're on the ISS and you're flying around the Earth and you're holding this piece of junk, you want to throw it in the opposite direction. So downstream that the ISS is going, and then you will give it a delta V, a momentary delta V. So if, say, the International Space Station is going at 28,000 kilometers per hour around the Earth, and you can huck this thing at, say, 50 kilometers per hour, maybe that's too fast, 20, this object is now going to be following the International Space Station, but it's going to be going 20 kilometers less. And the effect that's going to have is that's going to change its orbit shape. So, if, imagine, and this isn't true, but imagine that the ISS is following this perfectly circular orbit. You, by giving a one-time kick, is going to give your piece of space junk an elliptical orbit that is slightly offset from what's happening with the ISS. But it will continue to orbit. in this new kind of elliptical orbit. And, you know, is there a possibility that it could interact with the space station again? Yeah, because in fact, the weird thing that happens is that by giving it that kick, you change the sort of the periapsis and the apoapsis, the highest point and the lowest point of its orbit. And in fact, it will now be a little bit higher. It'll go a little bit higher than the space station is, and it'll go a little bit lower than the space station does, and that line will cross. And so you could actually endanger the space station on future orbits. And you can't throw it hard enough to deorbit it. But if you put a little rocket on it and had it fire that thruster continuously, then it would spiral in and get caught up in the atmosphere and burn up. So, you know, it's always a danger. If you kick anything overboard, it could come back and hit you later on. And the best way to learn this kind of thing is to play Kerbal Space Program. Like, you will learn so much about orbital mechanics by playing Kerbal Space Program. Busy Willie says, if you throw it in the opposite direction, won't you give the ISS a little kick to a higher orbit? Yeah, you will change the ISS's orbit a tiny little bit, but of course it's the amount of mass that you are throwing at what velocity that defines the kick. And it's going to be much bigger for the object that you're throwing than what the ISS receives. Astronomy. Are there any updates on the concept of ion engines for low-flying satellites fueled by gas collected from the upper part of the Earth's atmosphere? So this is an idea of an air-breathing ion engine, and I've done an interview on the channel, and we've done a bunch of stories on Universe Today about this, and this is the idea that, you know, instead of carrying your propellant on board, if your satellite is flying at a low enough orbit, then you could scoop up particles of the atmosphere, use solar energy to ionize them, and then fire them out the back of your spacecraft at really high velocity, like 10,000 kilometers per hour. And then that would give your spacecraft a thrust in the opposite direction. And so in theory, you could scoop up atmosphere as you're orbiting it low enough and then use that as an accelerant. And you wouldn't have to carry propellant. You would have no fuel on board your spacecraft, just solar electricity, which would be sustainable. And, you know, it's like people are trying to figure out a way to make this work, that we're currently in the engineering stage. Some people think the math holds and that this would work. It might work in better other worlds, like it might work on Venus or even on Mars or Titan. So stay tuned. It's an idea that I'm really excited about. And so I'm always watching for anyone to have made a practical improvement. But the interview that I talked about, you know, it's all still kind of in the theory and engineering prototype phase right now. So no updates. But an idea that I'm really excited about. Funky Critter, why is the Earth spinning? Will it stop eventually? The Earth is spinning because it's just the leftover momentum from all of the particles that collided to create the Earth. If you sort of take the average motion of everything that made up the Earth, you end up with a rotation. And will it stop spinning? No. The Earth is, you know, has been spinning for 4.5 billion years and will continue to spin until the sun engulfs us and destroys the Earth. Now, the speed that we are spinning is slowing down thanks to our interaction with the gravity of the moon, but it's only going to be a tiny little bit before the Earth is destroyed by the sun. Bazooka, Fraser, is it possible to revert all the movement in the universe in order to trace back the original origin of the Big Bang? The Big Bang happened everywhere. So there's no place where the Big Bang happened, and so you can't track that position back down. It is an expansion of space at every point, not an explosion that came from one place. Okay, we're in the last 25 minutes. I'm going to go into the speed round, which is where I'm going to try and answer the questions as quickly as I can and get through as many as I can. Menosanasis, any ideas on starting a space startup? It's a good way to turn tens of millions of dollars into hundreds of thousands of dollars. So far, there are very few space startups that have been able to not go bankrupt. So just understand the risks that you face in doing a space startup. If you can come up with a business model that is actually sustainable in the long term, then you will be the first person. Apart from SpaceX, very few space startups have been able to be successful. It's tricky, but obviously, it's exciting, and that's why we want to do it, and we want to, make the future happen, and that's great. So just manage your expectations and manage the expectations of your investors. Chris Nonia, is plasma in space alive? No. Plasma is just plasma. It's just ionized atoms. Let's see. Casey Ream, is the so-called vomit comet still part of astronaut training? Yes. There are actually private firms that will provide this service. So this is where you fly on this sort of up and down parabolic flight. And so you experience about a minute of weightlessness at the top of this flight as your airplane is then diving down, and then you experience 2Gs at the bottom of the thing, and then you go back up again. And NASA has its spacecraft called the Vomit Comet that they call the Vomit Comet, but you can actually take a flight in a zero gravity flight on your own. There's a company called Space Adventures that offers this, and often they will contract with NASA and other people who want to do experiments in weightlessness. Thomas Starkey, if there was an exact replica of Earth within 50 light years that has humans with our level of technology, could we even detect it with our current tech? Probably not today, but when the square kilometer array comes online in the 2030s, which will be a radio telescope, it could detect the air traffic control systems and other bright sources of radio emissions from Earth. So not today, but in about 5 years, yes. Rick W., how badly has Doge impacted near-Earth asteroid research? I can't think of any impacts, pardon the pun, from the government cuts on existing missions and ground-based observatories and the Vera Rubin telescope and all that kind of stuff. There's a NASA, is it the NEO Surveyor? So there's a couple of upcoming missions that would be helped to find asteroids, and I don't know if NEO Surveyor has been impacted by the new NASA budget. Jonathan Allen, is the song Lagrange by ZZ Top about Lagrange points? I have no idea. Adam Redwine, how do we spot jumbos if there's no star to illuminate them? Well, the jumbos that were discovered by the Jupiter mass binary objects that were discovered by James Webb, they're giving off infrared radiation. So Jupiter gives off infrared radiation because it is warm. And so even if you saw it in, super cold, if you couldn't see it visibly, you could potentially detect it in infrared. And so these things are newly forming. They're in this environment that is bathed in radiation, and they're giving off infrared radiation. And so James Webb is able to detect them. And they're warm from newly forming. Hey, Sasha, maybe a heavy question, but given the shared tech and science, do you have any thoughts about how space exploration science can be decoupled from the military? Not really. I mean, there's just tons of overlap, right? That the military considers space to be part of its warfighting domain, and so is an investor and provides funding for space exploration research, and it's always been the case. And I can't imagine a way, if you still need to have defense and you need to have satellites and you need to have rockets and you need to launch those rockets, that there's going to be overlap between military and civilian, non-military aspects of space and astronomy even. So I can't imagine a way that that would ever happen unless there was world peace. Oish, what up? If you're in a spacesuit, how long would you survive falling through Jupiter's atmosphere? Not long. You would make it maybe a few tens of kilometers down before the heat and the pressure built up to the point that you would die. Frosty Winnipeg, the gravitational lens thing is great idea, but how do you go to Pluto's orbit quickly? Let's say as quickly as New Horizons and stop. The problem is that to go into orbit around a planet like Pluto, I just called Pluto a planet. You're welcome, Pluto lovers. To get to Pluto, and if you want to go into orbit, you actually have to go more slowly. The New Horizons did a flyby. It went so fast that it was able to do a flyby. But if you want to go into orbit, you got to go on a more graceful, slower orbit that allows you to then, fire your rockets and then go into orbit around the target. And so it's a longer journey time-wise. 20 years. Annie Alexander, can international researchers compete for time on the FAST telescope in China, or does it have to be in association with a Chinese institution? Yeah, international researchers can absolutely get time on the FAST telescope in China, and I see papers about this all the time and report on it. So they're really good for international collaboration at this point. It feels it's sort of like the gold standard for how China could and should interact with the international science community. They're pretty good about their science instruments, not so good about the results of their sample return missions and their various missions. They hold that stuff a little closer to the chest, although they are getting better. But I think if NASA is the best, or the European Space Agency has some embargoes, so they're not quite as good as NASA. China is still trailing pretty significantly. And, come on, be better, China, right? Share the information. If you want to be seen as a leader in space research, you should be a leader in how that information is shared. That's what's going to be best. Parth Shah, can you get raw images from the C-Star S50? Yes. Yeah, you can put it into a mode that lets you download raw images. But it fills up the hard drive on that, so I don't. KGS, if an object with a certain size and density approaches the sun at the right angle and velocity, it would form an accretion disk around our star. Yeah, if it got within the Roche limit of the sun, then it would be torn apart and then would form a ring around the sun. But then eventually it would all fall into the sun. Right here, if quantum observers determine reality and we all see and believe the Earth is flat, would it become flat? No. Just because if we believe something, it doesn't make it true. So the universe has its own actual reality, and we make those observations. Now, at a quantum level, your observations can affect the position of a thing, but, at a larger scale, the observations have already been balanced out, and what we see is what is. We don't cause it. Mafusa Putasa, it's often stated that astronauts lose bone density. Does it just to get back to the baseline after some time on Earth, or does it stay at a slightly lower level for the rest of their life? No, they can get back to their regular levels. It just takes them a couple of years to work out and just be under regular Earth gravity, and they get back to where they were. There are other health conditions that, we're not sure, like seem to be cardiovascular issues that might last, but, muscle and bone, they can get back to where they were. Corbin, do current human-rated spacecraft have the space equivalent of a black box? I can imagine a future where as many spacecraft in orbit as we do airliners today. Yeah, I mean, I don't know exactly what it is, but like when there was the Challenger crash and the Columbia crash, there are instruments that the accident investigators were able to find that told what happened from the spacecraft's perspective, the last minutes before they tore up. Justin, can Webb observe all of its instruments simultaneously? No. So they have. I don't know if they can. I don't think so. This, you know what? I don't know the answer to this question, but my understanding, my instinct is to say no, that the light is coming through James Webb and it is directed into one of the instruments on Webb at a time, and various filters and whatever, and then they'll shift the light to move it into a different instrument if they want to make a different kind of observation. But I am not 100% sure. This is the kind of thing that I will review afterwards and know better next time. So I apologize. Tim Gordon, do you think NASA will land on the moon in the next 10 years? I personally don't think they will. Mr. Brain 4, what are the major consequences if the U.S. does not get back to the moon before other companies? No real major consequences, just a loss of pride, that a sort of a feeling of inadequacy amongst Americans, that they used to be the top nation in space exploration, and now it appears that China and potentially other nations are taking that lead, and they have to decide if they want to recover that lead, or if they want to focus on other things that they want to be good at, like building space telescopes or sending octocopters to Titan. So I think that for China, sending a human to the moon and bring them safely back to Earth is to say, hey, we arrived, we did it. We are a technological nation. We have the capability of the U.S. and anyone who's ever tried this. We can do it too. We can put a rover on the moon. We can bring samples back from the moon. We can put a rover on Mars. We can collect samples from asteroids. We can send a mission to Jupiter. We can build space-based gravitational wave observatories. We can build neutrino observatories at the bottom of the ocean. We are a highly technical society. We are a peer to places like the US and Europe. And if that continues on, then you may get to a place where everyone goes, yeah, the Chinese are just the best at all this stuff, right? Like if you want to be a aerospace engineer, you go to China. If you want to be an astronomer, you use a Chinese telescope. If you want to go to the moon, you hope you're one of the partner nations that's working with China, because nobody else is doing it, right? That's where that trend goes eventually. But, if China does it, then all they're doing is saying, hey guys, we get to be part of the club, right? Adam Renwine, besides Spin Launch, are there any serious mass driver startups? Not that I know of. I report on them occasionally, but they're really risky. Kristen Buriot, is Mercury potentially more habitable than Mars? I mean, somewhere near the poles where it's colder. You have to decide what habitable means. Mercury is airless, but there are large amounts of water ice at its poles where they're in permanently shadowed craters, just like the moon. And it's closer to the sun. And so the amount of solar energy that's falling on Mercury is more intense. So you could have smaller solar panels at Mercury than you would have to have them at Mars. There's higher concentration of metals and other useful elements on the surface of Mercury. So if that's the kind of thing that you're needing, then that's there. So they both have their pros and cons. They both suck. Manos Anasis, I have a friend that wants to start exploring astronomy, astrophysics, etc. What should I recommend him to make him passionate about the universe, assuming that he has no idea? I mean, there's so many great resources for people who want to become excited about astronomy. It depends on what they're into. If they prefer to kind of like mess with stuff visually, then help them get their hands on a small telescope like a Dobsonian telescope, or even just a pair of binoculars, and spend time with them. Go outside, learn the constellations, look for various objects in the night sky. If they're more interested in learning the underlying concepts, Crash Course Astronomy is great. It's hosted by Phil Plait, who's a superstar. And then obviously, we do the Astronomy Cast podcast if you want them to listen to that. So you kind of have to just be responsive to how they're interested in astronomy. Do they want to do this practically, or do they want to learn about cool ideas in space and astronomy? And then you can help guide them to this adventure. But, you can't make a person be into astronomy. You can only nurture the enthusiasm that they already have. Snellwood Cook, how do you pick the questions? I have a whole bunch of things that I'm looking for. I'm looking for questions I haven't answered, questions from new people, questions that I think I can give a good answer for. Guilt, how much time I have remaining. I sort of follow a whole bunch of multi-factor. B. Benoit, I keep hearing that Voyagers are now traveling through interstellar space, but I thought they were still well within the sun's gravitational influence and inside the Oort cloud. So which is true? Both are true. So interstellar space is the area where the particles that are being given off by other stars dominate the environment. So, when you are relatively close to the sun, within about 100 astronomical units, most of the particles that are going past your spacecraft are from the solar wind. And the solar wind creates this bubble around the sun. And then that bubble is sort of defined by the place where the solar winds from all of the other stars dominate the environment. And so the Voyagers have passed the bubble where the solar wind dominates, but now they're in the bubble, or they're in the area where it's a mix of all of the solar winds from all of the stars. But yeah, they're still within the sun's gravitational well. They're still well within the Kuiper belt, the Oort cloud. So it'll take them tens of thousands of years before they truly exit the solar system. So it just sort of depends on what definition you want to think about it at. But for, what kinds of particles are they encountering on a regular basis? They really are in interstellar space. Mad Monkey Oz, have you read the paper that says that Jupiter was twice as big and 50 times more magnetically potent? Yes, I have. We reported it on Space Bites, and we have a story about it on Universe Today. Danny Joe, do astronomers have any guesses on how often extrasolar objects pass through the solar system, objects big enough for us to observe? The estimate is that there are tens of thousands of interstellar objects passing through the solar system. Most of them are going to be too far away for us to observe, but Vera Rubin is coming online in like a month, and it should be able to find probably dozens of interstellar objects every year that we could then observe, and some of them we could send spacecraft and do flybys of. Frosty Winnipeg, I want to send Parker Solar Probe after Oumuamua. Does it have any cameras? It doesn't have good cameras for observing Oumuamua. And it's probably not on the right trajectory, so it would be really difficult to send the Parker Solar Probe after Oumuamua. But amazingly, Oumuamua is still reachable if we wanted to launch a spacecraft. If there was the budget and you took a Falcon Heavy and you put a tiny little spacecraft on the top of it and launched it, you could, with a really big kick stage, you could catch up with Oumuamua and potentially even go into orbit around it. And I've even reported on potential sample return missions from Oumuamua, that you could land on Oumuamua, capture a sample, and then bring it back home to Earth and study. Can you imagine what would happen if people could study material gathered from Oumuamua? That would be mind-blowing. Jan Prince, how many moons are tidally locked? All, or the ones closest with their planets? In general, moons are tidally locked to large planets. So the moon is tidally locked to the Earth. All of the Galilean moons are locked to Jupiter. All the big moons are locked to Saturn. All the big moons are locked to Uranus. All the big moons are locked to Neptune. That's just what you get. Church discography. Does the Earth have a wobble? Yeah, it has a wobble on its axis. It's called precession of the axis. It takes 26,000 years for this wobble to kind of go all the way through, and the seasons change throughout that process. Attila Berneker. Given Earth's crises, is expending vast resources on space exploration truly justifiable when its benefits seem so distant? To say that we spend vast amounts is kind of crazy, because we don't, compared to the other things that people spend money on. Think about how much people spend on cigarettes or the military or lawn care. It's vastly more than the amount that gets spent on space exploration. And space exploration is the thing that helps us monitor what we're doing to our planet. That thanks to space exploration, we have satellites that are observing the planet. The European Space Agency just launched a spacecraft that tracks trees to see what impact they're having on the environment. We can measure sea ice levels. We can measure water levels. We can measure methane emissions. So, of all of the kinds of ways that money is being spent, space exploration is one of those things that can actually help with us getting ourselves out of the problem we find ourselves in. And I think, why do we have to question space exploration? Let's take a big long list of everything that every human being spends. Sit down, make your budget, write down the big list, and then say, I watched Netflix and I spent $20 for Netflix. Is that the best use of my money, or could I spend that money planting trees? I think you can't really have a good argument about what we should and shouldn't be spending money about until you put the whole big list out there first, and then go through it, and then decide, are your priorities aligned? And right now, governments generally, societies generally, do not have their priorities aligned with the reality of what we're doing to the planet. And that's a shame. But, if I was to build that big list, investing in satellites capable of observing the changes that we're doing to the planet would actually be very high on my list of priorities, not low. Hanniskits, how tall must a pole with solar panels be to produce energy on the moon at the South Pole? It would have to be pretty tall. I think it's there are no permanently illuminated mountains at the South Pole of the moon. It's close, but there isn't any place that's perfect. You can get 98% of the time. Even though there are permanently shadowed craters, there aren't permanently illuminated mountains. And so you would have to build a pole, and I don't know how tall it would be, a kilometer or something, for always be in sunlight, and then just turning to face the sun. Adam Redwine, I've heard about statites that are like satellites, but balanced gravitational attraction with solar wind repulsion. Is the tech being researched? Someone wrote a paper. I interviewed the guy who wrote the paper, but nobody is actually building these things. Attila Berigi, are you aware of any planetarium program that can show the stars where they are instead of where we see them? In other words, that can compensate for the light delay time. Not that I know of, but it's not that big, how much will a star have moved in 20 years is not very much compared to its current position. But Gaia is if you wanted to do it, you could probably come up with a way of doing it with Gaia. And it would be cool to kind of see a comparison back and forth. We show this is the sky of what we see, and this is the sky based on where things have moved. And it would look almost identical. The farthest stars that we can see are maybe 700 light years away. I think Betelgeuse is 640 light years. I'm not sure exactly what the farthest star is. So how much will Betelgeuse move in the sky over the course of 600 years? Not very much. Tiny little bit. A detectable amount by very powerful telescopes. But if you looked at the sky, it would look identical. And then you'd be like, wait a minute, if I really zoom in, isn't that star just moving 1 pixel back and forth? Dougal, if mainstream media asked you for an interview, would you attend? Sure, yeah. I get asked to do interviews by the mainstream media all the time, and I always say yes. Always happy to do it. I just gave an interview for a Christian podcast as an atheist. Happy to do it. Casey Butler, do you think evil exists anywhere else besides Earth? I mean, if there's alien civilizations and they have a variety of personalities and some of them will be evil, by my definition, then yes. But I think that we're alone in the universe, so I don't think there's any evil besides Earth. Random castings. I recently listened to your interview about the YouTube algorithm hurting when doing interviews. Would it not be advantageous to launch a channel, University Interviews? P.S. I think the interviews are the best. I just don't care. Like, I don't care what the YouTube algorithm wants me to do. So I'm not going to respond, right? If the YouTube algorithm tells me that, you're doing these interviews and they don't get as high watch ratios compared to shorts. And if you're not going to do shorts, then we're going to punish you. Do your worst, YouTube. I just don't care. I'm going to do what I want to do. And I know that the content that I create is interesting to an audience, and I have enough alternative direct ways of letting my audience know the things that we're doing, and I'm just going to keep doing that. Like, you go crazy trying to, like, imagine I got to set up a whole new channel. I got to migrate the videos from one channel to the other channel. I've got to, manage the way that I present those multiple channels, and only to just appease an algorithm that may change its mind tomorrow. I don't care. I'm not going to do it. No, absolutely not. I'm just going to make videos, put them on the channel, and we're just going to go. The fact that we even make these live streams unlisted after the fact feels like a bridge too far. That I'm already caving to the algorithm, and I may change my position on that. So, yeah. Okay. Whoa, you did it. You tricked me. I went longer than the normal 2 hours. So we should wrap things up. Thank you, everyone, for hanging out with me. Of course, for Zapfan and John Suffield, in Europe, this is like their time. So normally, I'm sure they're getting so sleepy, but this time, they're just getting going. So, Peter, you were never shadow banned. Never. You were maybe timed out for saying stuff. Anyway, thank you, everybody, for hanging out with me today for the live stream QA. I really appreciate it. Thanks in advance to Chad and Anton, who get to edit this nonsense together. A huge thank you to the moderators. So give a big shout out to the moderators for helping pull these into my database so that I can make this as quick and efficient as humanly possible. Let's find out what was the final tally. How many did I answer? Oh, I don't know if I can find out how many I answered. Will it tell me? Yeah, it will. Okay, hold on. Although, of course, I did a bunch of answers quickly. So it's about... there's 88 unanswered left. So, all right. Thanks, everyone. Going to release an interview today about solar sails, which is really cool. And another interview later on this week, plus 2 question shows, plus Space Bites on Friday. Astronomy Cast starts in an hour with Dr. Pamela Gay, so it's going to be a busy week. All right. We will see all of you next time. Thanks, everyone.